we have to prove the sum of angles using sum of angle this. So let's use left hand side. Cos twice a means a plus a, so we can write using this formula cos a cos b, this angle b is also a, so cos a minus sine a, so we can write cos squared a minus sine squared a. So we have to express in terms of sine square only, so using the identity cos square is 1 minus sine squared a, so minus sine squared a, so is 1 minus 2 sine squared a. So therefore left hand side equal to right hand side. So then for question number B, we can take left hand side again. We can write 2 sine 2 theta minus 3 cos 2 theta minus 3 sine theta plus 3. Now here we have to use this. Sine 2 theta is 2 sine theta cos theta, and cos 2 theta we already proved 1 minus 2 sine squared theta, so that's what we have to do here. So let's start breaking it down. So 2 sine 2 theta means 2 sine theta cos theta minus 3 cos 2 theta means 1 minus sine squared theta minus 3 sine theta plus 3. This means 2 sine theta cos theta minus 3 minus minus plus 3 sine squared theta minus 3 sine theta plus 3. So what we can do here is we can cancel this plus 3 and minus 3, and we can take sine theta common. So if we take sine theta common, so it would be 2 cos theta plus 3 sine theta minus 3. So this is what we will get, but there must be a problem here because I forgot to write here 2. 1 minus 2 sine squared theta, so 3 ones are 3, this should be 6. So if this is 6, so this should be 6 sine theta, then this should be minus 3 sine theta if I take sine theta common. So this should be 2, there is a 2 here also, so 2 2s are, this should be 4, so this should be 4, so 4 cos theta plus 6 sine theta minus 3. Okay, now it is correct. So this is what we have to prove. So left hand side equals to right hand side proved. Question number C is that sum again. If you remember, when we have an expression a cos theta plus b sine theta, we have to express it in the form of r theta minus alpha. So the formula is r squared equals to a squared plus b squared, and for the value of alpha we have to write tan alpha in terms of sine alpha by cos alpha. So that's what we have to do. So let's start here. So 4 cos theta plus 6 sine theta equals to r sine theta plus alpha. So therefore r square equals to 4 square plus 6 square, which means 16 plus 36, which means 16 plus 36 is going to be 52. So 52, therefore r equals to plus minus square root of 52. Now we don't have to write down the answer in any decimals, and r is positive, so r is going to be square root of 52. Now after that, the next thing we have to find is alpha. So for alpha we have to break this thing down. So let's break this thing down. So sine a plus b is going to be sine a cos b plus multiplied by r cos a sine b. So that's how we have to break this down. So now if we compare, we need sine alpha. So for sine alpha we need to compare cos theta left hand side, right hand side. So cos theta, so here cos theta has r sine alpha So equals to, and this side cos theta has 4 divided by sin theta has r cos alpha, and this side sin theta is 6. So the r and the r cancels. Sin theta by cos theta is tan alpha, and 4 by 6 is going to be 2 by 3. Now here you don't have to solve the equation because this is just find the value of alpha, so just do inverse. So alpha equals to tan inverse of 2 by 3. Now one thing is very, very important, it has to be in radian. Be very careful. C4, most of the things are in radian, so convert the calculator. 1 2 3 4 5 6 2 3, so radian 2. So this is going to be tan inverse 2 by 3, 2 by 3. So this is going to be 0.58880. So 0.588002003. So now we can write the main answer. The main answer would be r square root of 52, and alpha is 0.588. They didn't mention anything, I'm just writing 3 decimal places here. So the final one is question number D. So question number D is hence solve this. Now if they ask the question hence solve this, it has to do something with the previous sum. So for question number D, if you write 2 sine 2 theta equals to this thing, if you notice 3 cos 2 theta plus sine theta minus 1. So this is the equation. Again, this is in radian in 3 significant figure. So this is something that we have to solve. Now for solving this, what we can see is this is 2 sine 2 theta, this is 3 cos 2 theta, this is 3 sine theta, this is minus 3. So this is 3 cos 2 theta, this is 3 minus 2 plus sine 2 theta, and this is minus 3 equals to 0. So this is the expression that we have here. Well, you see, this is going nowhere. It's becoming something very strange. So take their hint. They said hence, so that means it's a good idea to take the help of the previous sum that we did. If you notice here in the previous sum we have this 4 cos theta plus 6 sine theta. Take a note here, in the previous sum we have this, and even before this we have something like this. Just keep this in mind. We have something like this, 2 sine 2 theta minus 3 cos 2 theta minus 3 sine theta plus 3, the previous sum. So when you have this final sum, it is a connection and it is going on like that. So let's start this all over again to see when we use this hence how easy the sum becomes. So let's get back and do this very quickly. Because when they give hence, we just have to use the previous sum. Okay. So when we have this, we can easily write 2 sine 2 theta minus 3 cos 2 theta minus 3 sine theta plus 3 equals to 0. Now again, if you take a look at the previous sum, what we got is exactly what we proved. That's how straightforward the sum is. We proved 2 sine 2 theta minus 3 cos 2 theta minus 3 sine theta plus 3. Exactly this is equals to sine theta 4 cos theta plus 6 sine theta minus 3. This is exactly what it writes. So this is going to be, so instead of this expression we can write sine theta, this is going to be 4 cos theta plus 6 sine theta minus 3 equals to 0. So we can just break it down. As a matter of fact, we can even break it down further, because the previous sum was express this little thing as r sine theta plus alpha, which we already did. So we can even write sine theta, and instead of 4 cos theta plus 6, we can write r, which is root 52 sine theta plus alpha is 0.588 minus 3 equals to 0. So we can even write that. So we have now two situations. For sine theta equal to 0, we know when sine theta is 0, 0 degree, 180 degree meaning pi, and 360 degree means 2 pi. For square root of 52 sine of theta plus 0.588 minus 3 equals to 0, so we can write sine theta plus 0.588 equals to 3 by square root of 52. So let's draw the quadrant and the basic angle. This is the quadrant, so sine positive first quadrant and this quadrant. So therefore the basic angle is going to be theta plus 0.588. Remember C2 rule, you cannot break this basic angle. So sine inverse of this is going to be 3 by square root of 52. Remember, you cannot use degree here, it's a radian sum. So we can do this sum using radian. So the calculator is already in the radian mode. So we do sine inverse 3 divided by square root of 52. 3 divided by square root of 52. Bracket close. So this is going to be 0.4291. 0.4291. So the first one is going to be first quadrant. So theta plus 0.588 equals to 0.4291, and this is in this quadrant. This is going to be theta plus 0.588 equals to 180 means pi. Remember, this is in radian mode. Point basic angle 4291. So which is going to be pi, no, this is pi minus 0.4291. So 2.7125. 2.7125. So let's write down the answer. Theta equals to, now we have 0, we have pi, so this would be included, 0 and pi. Then we have this one, so theta is going to be 0.4291 minus 0.588. So this is going to be 0.4291 minus 0.588. This would be negative. So this is not possible. So this value will not be possible because this is a negative value. The next one is 2.7125 minus 0.588. This one is, so this would be 2.12. So let's check what the range was. Let's check this again. Okay, it was equal to 0 and less than pi, so pi cannot be included, and 3 significant figure. So the answer would be 0. We cannot take pi, so this will not be taken, and this is 3 significant figure. So this is the answer.